Okay, our video is going to look at pressure, volume, temperature, and STP. So our second tab here. We're going to look at the definitions and then some of the relationships that we're going to be using. So when we think about pressure, if we think back to our kinetic molecular theory discussion, we talked about those collisions, either with other particles, so gas particle to gas particle, or gas particle to the wall of its container. When we're talking about collisions, we're talking about pressure. So pressure is going to be by number of collisions. When you think about it, the more collisions, more pressure. So more collisions, more pressure. So the opposite would be true too. Less collisions, less pressure. Now, volume, we are always talking about the amount of space something takes up. So when we're talking about volume, we're talking about the space. Then when we are talking about temperature, we talked again in that kinetic molecular theory about the speed of the particles. And that's exactly what we're talking about here. So speed of particles. More speed equals a higher temperature. So less speed or lower speed equals a lower temperature. Then let's talk about STP. So STP stands for standard temperature and pressure. So standard temperature is going to be 0 degrees Celsius or 273 Kelvin. And standard pressure is 1 atm. Now when we think back to when we did our conversions here, you'll notice that all of these are equal to 1 atm. So all of these are standard pressure. And 273 Kelvin is standard temperature. So that can be a way to help you remember that STP. Now let's talk about relationships. So when I'm looking at this graph between pressure and temperature, you notice as one increases, so does the other. Okay. So when that is the case, we call that a direct relationship. It means that they move in the same way. Now when we go in to do our math modeling for this, we're going to be using arrows to identify relationships. So if a relationship is direct, it's going to be up, up, or down, down. So our two variables, pressure and temperature here, are going to move in the same direction. Now if I look at volume versus temperature, we see that it is the same type of relationship because our graph is the same. So we know that this is a direct relationship. So again, same. As one increases, the other increases, or as one decreases, the other decreases. And you can see that because as temperature goes up, so does my volume. Now when we're looking at pressure versus volume, we notice that that has that curve to it. So it's not that nice straight line like we were seeing in these first two. As volume gets smaller, so when I'm looking at my x-axis here, getting larger, pressure is getting smaller. As volume is getting smaller, pressure is getting larger. So they are doing the opposite. So we call that inverse. So these are opposite. As one goes up, the other goes down. Or as one goes down, the other goes up. So since I misspoke, let's walk through it again. When volume is small, pressure is high. When volume is high, pressure is low. Small volume, large pressure. Large volume, small pressure. So those are our relationships. You'll notice that when temperature is present, they are direct. So that's usually the easiest way for me to remember it. So if temperature is there, it's direct. And if temperature is missing, pressure versus volume, then it is inverse.